Hello, this is my Physics 2212 Lab 3 video walkthrough on magnetic fields of a bar magnet. The goal of this experiment is to measure the distance dependence of the magnetic field due to a bar magnet. And the method used is by using a magnetometer app to orient the bar magnet to be exactly orthogonal to the Earth's north and south magnetic poles so that it is removed from the equation and doesn't affect our calculations. Next, we would find the exact location of the magnetometer chip in our phone by laying our phone vertically and then horizontally, respectively, and in each case sliding it perpendicular to the bar magnet until the maximum x component and thus minimum y component is found. Then we will find the distance from the magnet to the sensor that produces the various exponent magnitudes at 20, 70, 120, and 170 microteslas. We will then use this experimental data and the subsequent plot generated by Excel to determine our n, k, and from k, the magnetic moment mu values. We will also use the experimental data to measure the off-axis magnetic field and compare it to our computed values in GlowScript. Some important laws and formulas to consider. The basic laws of magnetism that every magnet has two poles, a north and south, that are equal and opposite of each other in magnitude, and the idea that like poles repel while unlike poles attract. Some formulas used throughout this lab. The formula to find the magnitude of a magnetic field of a dipole on axis, as well as just the general formulas to find the magnitude and vector of a magnetic field. Here's a screenshot of my Excel data. On the left side, you can see my observed values at each R point, as well as at the bottom, the calculations used to find the off-axis field. And on the right side, you can see the plot that was generated from that, which we will go into more detail in a second. Analyzing some of the Excel data, as you just saw, the equation for magnetic field due to a bar magnet, we use B bar equals KRN, and then can take the natural log of all that to get natural log of Bx equals ln k plus n times ln r. And from the plot of ln Bx versus ln r that was generated in Excel, it gives somewhat of a y equals mx plus b equation where we know that n is equal to the slope, which is negative 2.974, and the natural log of k is the y-intercept, which is negative 14.32. And from the natural log of k, we can find that k itself equals 6.05 times e to the negative 7th. Furthermore, from that value of k, we can find that the magnetic moment mu is 3.025, which is found by this equation, mu naught divided by 4 pi times 2 mu is equal to k. Here's some screenshots of my GlowScript code, where on the left side you will see the function used to create the original magnetic field, and then everything else is used to find observation locations and arrows to represent both on-axis and perpendicular magnetic fields. And the very bottom right is used to show the 45-degree axis magnetic field from distance d. The model and output from my GlowScript code, the red arrows represent the on-axis, the blue arrows represent the perpendicular, and the small purplish pink one at the top right represents the 45-degree magnetic field. And as you can see, if you notice, the d value equals to 0.2687 meters is nearly exact with the value found through the experiment. Some additional questions to consider. What if we hadn't oriented the experiment to compensate for the magnetic north and had just laid it out at some random angle with respect to the Earth's magnetic field? The magnetic field definitely would have been larger because it would have been impossible to differentiate between the magnetic field due to the bar magnet from the magnetic field due to the Earth's, magnetic field. And since we didn't, and if in this case, if it weren't orthogonal, there would have been no way to kind of remove that from the equation. Next question, what if you were to stick two identical magnets together end to end and run the experiment again? How would the measurements differ? I don't think that the measurements would significantly change because when you stick two magnets together end to end, it essentially just creates one larger magnet, but the poles of the magnets shouldn't change much, if at all, in magnitude, which means that the measured results also shouldn't change. Thank you for watching.